to get the evidence, which is memdump.7z. It's 130 megabytes. I made it from an old Windows XP machine with, I think, 256 megabytes of RAM and zipped it. So you have to unzip it and get memdump.mem. Now this, by the way, hashcalc doesn't exist anymore. I should get this out of this project. Let me try refreshing and seeing if that, yeah. What you can do, you use PowerShell. It's get image info. So I'll demonstrate that. So I should have memdump.mem somewhere. Let's try my downloads and see if I've got it. Mem. I have memdump.7zip. That's good. And there's memdump.mem. Okay. So here's the 7-zip file, which is compressed and 127 megs, and here's the unzipped one that's 525 megs. That looks good, but I'd like to verify the hash value of that. So what I want to see here, there's MD5 SHA-1. I'll just do the MD5. So what you do in modern versions of Windows is you open PowerShell. And then you go to that folder, which is downloads. And then just do a directory of mem*.star, make sure I'm able to find the file. There it is, memdump.mem. So it's get-file hash, algorithm, MD5. And then I forget whether I need to specify file. Let's just go to an earlier project. I think in this one, I had the correct format of this command. Not that one, must be the next one, this one. There we are. This is get file hash algorithm, then just the name of the file. Okay, that's the command you need. Yeah, so all I need now is memdump.mem. There, that should do it. I'm not using this, what is this garbage? I don't want to update at all. Pick a time. Okay, all right, there. So the hash starts B50, and the right hash for this project is B50. Okay, so it's fine. So that's what we want to do. You always want to verify the hash before you trust evidence, because you might have had trouble downloading it or something. All right, so now I got to run autopsy and run the experimental module, because memory analysis is like an experimental optional feature in autopsy, which is very nice. It's just using a command line tool for memory analysis, volatility, I think, which is the old way to do it, and it was very confusing and difficult to use. Building it into the GUI makes it a lot nicer. But it is experimental, and they do change things. Sometimes students find that the new version can't find the exact thing I was looking for. So I make a new case. I'll call it mem, and next, case directory. Already exists, fine. All right, I'll call it mem2. All right, mem2, finish. All right. Now, I have to go Tools, Plugins, and go to Experimental to enable them. Okay. They may already be enabled in this copy of Autopsy, but I'll verify that. Tools, plugins, okay. I don't think I can do it while this is going on, though. Some server did not respond for something. Yeah, there's always something. A lot of wind today. All right. Well, if that's going to take time, I'll check the Twitch and see if there are comments. When are quizzes due? Oh, good. Somebody noticed. Yeah. Good. All right. All right. Ah, now I think it's ready. Okay. Oh, I should have just closed it. I see. I kind of hosed. I wasn't supposed to do what I've done. Let's see if I can get to the Tools menu now. I might be in trouble. Tools. I'm pretty sure it's already enabled though. I should have done it before opening a case. I'm going to assume it's okay and move ahead, make a new case, and import the memory image, memory file, volatility, that's the tool. All right, there we are. So I think I've already turned on those features on this machine, so I'm not going to start over because it's too slow. So I don't care about the host name, but it is a memory image. There it is, a volatility file. Next. And now, it is, because you won't see this if you haven't turned on the experimental feature. These are all the things it can find in memory. It can find the command line things you've been executing. It can find the libraries you've been using, the registry, environment variables, all kinds of things are present in memory. Now, each one of these is a separate volatility command, and the volatility command takes some time to run. So if you check them all, it will take a while. So what I did was, you could just check them all, but if you want to speed it up, just check the ones you need, which are like this 6 or 8 consoles. These are the particular ones that I found had interesting results on this image. And this image is from an old Windows XP machine because it was a small image I had around. So that's what I've already done here. I've already cleared them all and checked just a few of these things to make it as fast as possible. So once you've done that, well, I have to put the image in here though, which is going to be downloads memdump. Wonder if I can just type it. I think I can just type memdump.mem and it will find it. Yep. All right. And next. Okay, I'm here. Okay. And for this one, configure ingest just next. Okay. And then let it go. All right. And I don't think it's worth waiting for. The pictures here are right, so you'll see things. So consoles will show you the commands typed in, and this person was creating user accounts with the net user command, which is what you do at the console in Windows. And so you'd be able to see what password was on these accounts that were created. So that's one flag to find. Hash dump is something you'd be used to if you're doing the hacking class. There's the password hashes to get the Windows hashes. The hash dumps look like this. This long mess at the end is an NTLM hash, the current system Microsoft uses. And so if you have that number, you can then crack it with a variety of tools like John the Ripper and stuff like that. This is a common thing you do in forensics and in hacking. You steal the hashes and then you try to crack them and get the password. So that's an important thing to get. Here's LSA dump. There is something called LSA secrets, especially in earlier versions of Windows, and it actually had the administrator password sitting here unencrypted on all the Windows XP boxes. It's kind of disgusting. So if you can look in memory, you can totally find it. And it's true of this one too. The administrator password is there. And you can go to NetScan, and it will show you that the same thing NetStat would tell you. It shows you all the listening ports. You can see what service was listening on port 8080, and so on. You can see all those programs that were running and what network connections they were making, which is why memory dumps are so important for forensics. If it's infected with malware, and it's doing something, you'll see it in the running processes, and you'll see it in the network connections and so on. That's why an image of the hard drive is not at all the important thing for incident response. If you're trying to deal with infected machines and active attackers, you want the memory. You want the hard drive too, but the memory is essential because you want to see what's going on right now. And then there's PS, this is the list of running processes. So you'll see all the running processes and something about how much memory they're using and stuff. You see the names like it's running Notepad and Internet Explorer and another copy of Notepad and Adobe ARM and so on. Or VM tools because it's a virtual machine. You can see all the various processes that are running, and one of them has a flag. And shell bags store information about what windows were open and where they were. And so you can see what kind of windows have been open recently. And in this case, we're going to find the shared folder this machine was connected to. It was connected to a server in the shell bags, recorded the fact that it connected to a file on a shared folder in folders / something. So you find information about network shares. And then user assist is the famous one. This user assist records what you've been running. And so you'll be able to find a dangerous program that was run here, an obviously malicious program that was run from downloads. They downloaded something and they ran a dangerous program there because I was using this machine to make hacking projects. And then there's a probe account. This is one you have to crack a hash. I made it extra credit. You can find online tools to crack hashes, and if you're taking a pen testing course, there's tools in Kali Linux to crack these password hashes. And of course, it's not a very difficult one. I chose a fairly common password. So you'll be able to take the hash that you got back up here and crack it. By the way, you can often crack Windows password hashes by just Googling them, because they've never changed it since 1993. So people have just made lists of them online. And so if it's a fairly common password, it will just find it because somebody's posted a list. It's ridiculous. Microsoft doesn't salt their hashes. Linux does and the Mac does, which means if you type in a password, it adds like 8 random letters before hashing it, so that if somebody else uses the same password, it's a different hash. Microsoft never got the memo. This became a standard thing in Linux in 1975, but Microsoft hasn't got the memo yet. They're still using unsalted hashes. It's one of the many very disturbing security decisions Microsoft has made. Anyway, it's handy for attackers. All right, and that's what I wanted to show you. Yeah, it's still running, but it doesn't matter. I showed you where it's going. So I'm going to stop this recording.